let's take a look at a particular polygon and see if we can use that to form a tessellation. So let's start with a stop. In fact, let's start with the stop sign. So let's take a octagon and see if we can tessellate the plane. Let's just try it first. The first thing to do always in life is try it. So we put them together in some way. Put these two together. That seems pretty good. Now, here I'm in a little bit of a bind, right? Because it doesn't fit in there. Do you see that? It just doesn't fit. Remember, there has to be no gaps at all, and there can't be overlaps, so I can't do that. And so this is not looking good. Now, is there another way to do it? No, then it doesn't fit that way. Looks like I can't do it. Let's see if we can confirm that somehow. Well, let's actually figure out what the angle is here that we're making here. Well, we can actually figure that out in a variety of ways. You might actually know that if you have an octagon, then the angle here is actually 135 degrees. If you know that, I'm impressed. If you didn't know that, you could actually figure it out pretty easily, though. Let me show you how you figure it out. Just draw a couple of quadrilaterals in there. This actually is a rectangle inside there. We know all those angles are 90 degrees, so we know that's going to actually be 360 degrees. This trapezoid, the angles there are 360, so it's 3 times 360. So the total number of, the measure of all the angles is 3 times 360, which is 1,080. Now there's 8 angles, so if we take 1,080 and divide by 8, since all the angles are the same, it's regular, we see the 135 that you might have already known. Anyway, 135 is the degree. Now, if this is going to actually be a tessellation, that means that once around, which is 360, that number has got to be a number which has this angle as a divisor. 135 has to divide in evenly into 360, otherwise we'd see a non-fit. Well, we see that 135 is not a divisor of 360, and so if you try to divide on the calculator, you'll get some decimal stuff left over. It doesn't go in evenly. So therefore we see it can't match up perfectly because it just won't match. That's what you're visually seeing here with that little white spot. How about a couple of equilateral triangles and some squares? Well, they match up sort of perfectly there. Let's see if we can make a go of this. First of all, how would they have to come together? Well, an equilateral triangle has angles 60 degrees. Squares have each individual angle of 90. So 90 and 90 is 180, and 60, 60, and 60 is 180. 180 and 180 is 360. So hey, wait a minute. I should be able to use 3 of these triangles and 2 squares. Oh, check it out. Oh, is this too good to be true or what? Do you see it? I think we might actually be able to tessellate with these equilateral triangles and these squares. Look how beautiful that is. Let's see if that really is okay. See, 360, that's all that matters here is that we get 360. Let's see if we can get some stuff going on here. So I gotta have the 2. And this would be, by the way, semi-regular. Look how beautiful that looks. Does it look attractive? I think so. Wow. And you can start to see it fill up space with this pattern that repeats. And repeats and repeats and repeats. You just can't help yourself. I want to stop. I really do. And yet I can't. Look at that. And even the colors, I think, go quite nicely. I think the colors are quite nice together. All right. I want to keep doing this. But I think you know what? I'm not even going to stop. I'm just going to keep doing it and enjoy it. But you can see how it fills up space. A beautiful tessellation. And you can see that the angles work out perfectly to add up to 360 degrees at every single vertex. So we've got a wonderful tessellation. Anyway, enjoy the tessellations all around you. You should make up your own. Look, I'll put little horns on this one. Fun.